In this lesson, we're going to talk about translating and inequality applications. Let's go ahead and first begin by looking at this first slide here. We want to go ahead and distinguish the difference between expressions, equations, and inequalities. So I'd like you to go ahead and pause the video and see if you can circle all the expressions, put a box around all the equations, and then underline all of the inequalities below. All right, now that you've taken a second to try that, I'm going to go ahead and I'm going to begin by circling all of the expressions. All right, go ahead and check your answers with me. Now I'm going to go ahead and put a box around all of the equations. All right, and I'm going to go ahead and finish up by underlining all of my inequalities. All right. Hopefully you were able to match those up. That's a nice little review of the differences between expressions, equations, and inequalities that we've been learning over the past couple of units. All right, let's go ahead and talk about inequalities now. Inequalities kind of look like equations, but they have these four symbols. The first symbol is the greater than symbol. It's also represented as is more than and exceeds. So when you see that symbol, it means all three of those things. Then we have the symbol less than. Is less than or is fewer than represents this symbol. Followed by the is greater than or equal to, or is no less than, or is at least. And then finally, is less than or equal to, is no more than, and is at most. So basically, the difference between inequalities versus equations and expressions are inequalities have multiple answers. They have infinitely many solutions. So we're going to be using this terminology to translate some inequalities. This is going to look very familiar to what we've done with expressions. All right, let's go ahead and translate the inequalities. Here it says 6 is greater than triple a number. Now, the difference between an inequality and what we've done in the past is the word is. So whenever you see the word is attached to one of our inequality word phrases, like greater than, that represents an inequality. Let me show you my annotation. 6 is greater than. So that's going to be the symbol like this. Is greater than. Now, if it was just greater than, we would actually be adding and we would be switching our terms around, just like we learned a couple units ago. But this is going to be is greater than, so that's going to represent the greater than symbol. And then we're just going to go ahead and continue and say triple a number. Triple a number is going to be times 3, and then a number represents our variable, x. So if we were to translate this, that would be 6 is greater than 3x. And we're done. Let's try the next one. 5 plus a number is fewer than 9. Okay, so we have 5 plus a number is fewer than. Is fewer than is going to be our inequality, and that's going to be represented by the inequality less than. And then we'll finish it off by putting a 9 there. So if we were to translate this, that's going to be 5 plus x is fewer than 9. Okay, let's try the next one. Double a number is at least 20. Double a number means times 2. Please forgive me my voice. I'm losing my voice. A number is at least. All right, is at least is going to be the inequality that is represented by this symbol. And then 20. So double a number is at least 20. And feel free to use that little cheat sheet that's in your packet to help you with these symbols. 3 is no more than 7 minus a number. So here we go. 3 is no more than. Is no more than is going to be our less than or equal to symbol. 7 minus a number. So here we go. 3 is no more than 7 minus a number. And we're done. Let's try a couple more. 3 subtracted from a number exceeds 12. All right, let's go ahead and annotate this. 3 subtracted. If we remember from our previous unit, we talked about the switcheroo words, from, than, and to. From is a switcheroo word, so we're going to go ahead and switch it around. I'll show you what that means in a second. So 3 subtracted from a number exceeds. Well, exceeds is going to be our greater than symbol, 12. So you can see that with our switcheroo word, we have this chunk here, this 3 subtracted from a number. And that whole phrase comes before our inequality symbol exceeds. So what we're going to do with that is we're going to switcheroo within those brackets. So 3 subtracted from a number is going to look like this, x minus 3. And it's going to be followed by exceeds 12. And we're finished. The next one, let's go ahead and annotate. 10 is less than, that's going to be our symbol is less than, the product, which is multiplication, of 4 and a number. All right, so let's go ahead and translate this. 10 is less than the product of 4 and a number. There it is. All right, the next one. 9 more than a number is no less than 15. So 9 more than a number is no less than. Is no less than is going to be greater than or equal to 15. Now, you might have wondered, well, why isn't at the beginning the more than an inequality symbol? Because there's no word is there. So 9 more than is going to be a little switcheroo. So again, we have to look at where our inequality is located, and we have to see everything that's before it. This is the piece that I'm going to be doing the switcheroo with. So 9 more than a number is going to be x plus 9. Then I'm going to go ahead and tack on my inequality symbol, 15. And the last one, 3 less than a number is at most 5. So 3 less than a number is at most, that's going to be my inequality. That's going to be my less than or equal to inequality, and 5. I do have a switcheroo here, so I'm going to go ahead and switcheroo everything that is going to be before my inequality. So 3 less than a number is going to be x minus 3. And then I'm going to go ahead and tack on my inequality. And I'm finished. Now that we've done some translations, let's go ahead and talk about some applications. These are 2 examples of 2 one-step inequalities. Let's go ahead and look at the first one. You're at a supermarket and you are allowed to spend at most $40. You have already spent $29 on food. Find the possible amount of money you can still spend at the supermarket. So we want to construct an inequality here. So the inequality that we're going to use here is we have to think about some words that we're given. You can see from the very first sentence that we're given the phrase at most 40. That means that we're going to be using the symbol less than or equal to. And so less than or equal to what? Well, they gave us the number 40. So I'm going to go ahead and write at most 40. Now let's see what we can fill in on the other side. You have already spent $29 on food. And we want to know how much more money can we spend. So if we've already spent $29, we're trying to figure out, well, how much more can we spend so that we can only spend at most 40. So this is going to be our inequality. Now let's go ahead and solve our inequality to get our answer. Using our skills of solving inequalities, I'm going to go ahead and put a box around my variable and draw my line down my inequality. And now I'm just going to go ahead and solve it just like I would an equation, and just like we've practiced already in this unit. I'm going to subtract 29 from both sides since 29 is a positive number. My 29 minus 29 is going to turn to 0, and I'm left with x is less than or equal to 11. So I end up with the inequality x is less than or equal to 11. So at most, we can spend up to $11. So we can spend $1, $2, $3. We can spend $10. We can even spend $11 if we want. But we can't go over $11 because that would take us over our budget of $40. So in our little therefore statement off to the right, let's go ahead and write our inequality as a statement. Let's say we can spend at most $11. And I'm going to go ahead and put my inequality in there. X is less than or equal to 11. All right, let's go ahead and look at another one-step inequality. Dustin and his best friend Jeremy found some money buried in a field. They split the money evenly, each getting more than $24.28. How much money did they find? All right, let's go ahead and see if we can come up with an inequality. So in the first sentence, it says that they found some money in a field, and then they split the money. See the word split? Split means that they're going to cut it in half. So that means that we're going to take the money that we don't know how much it is, and we're going to cut it in half. So we're actually going to divide that money by 2. Now, each of the boys are going to be getting more than $24.28. So let's use our more than symbol, and let's say more than $24.28. Now let's go ahead and solve our inequality. To solve this inequality, we're going to go ahead and we're going to box our variable and draw our line. And it looks like right now x is being divided by 2. So we're going to do the opposite operation, and we're going to multiply it by 2. On the left side, those 2's are going to cancel out. And we're left with x is greater than, now feel free to use your calculator. We want to do 24.28 times 2, which is going to leave us with $48.50, 56 cents, I'm sorry. So, what this means is that both of the boys are going to get more than $48.58. All right, and I'm going to go ahead and tack on my inequality there and as part of my answer as well. All right, now let's go ahead and look at some two-step inequalities. Alex sells books online. She makes a flat profit of $2 per book, but she needs to pay $4 per day to PayPal for using the app on her website. How many books does she need to sell to make at least $120 per day? All right. Let's go ahead and see here. So Alex is selling these books online, and she's making a profit of $2 per book. And at the end of the day, we're trying to figure out how many of the books does she need to sell. So really, the variable that we're searching for is the number of books. So if she's charging $2 per book, I'm going to represent that by saying 2 times our books, because we don't know what our books are, how many books there are. So $2 per book. And we also know that she needs to pay $4 per day to PayPal. And that's kind of one of those things that you automatically have to do. So she's going to lose $4 no matter what. So I'm going to say that she loses $4. Okay. Now, it says at the end, she wants to make at least $120. So at least we're going to use the symbol greater than or equal to. And I'm going to set that inequality to 120. Now let's go ahead and solve our two-step inequality. I'm going to put a box around my variable, draw my line. I'm going to begin by eliminating the -4 by adding 4 to both sides. Make sure to line everything up just like we have been in this unit. So 2x is greater than or equal to 124. Now I need to take one more step and just divide both sides by 2. So x is going to be greater than or equal to 62. So what does that mean? That means that that's how many books she needs to sell to make at least $120 per day. So that is the goal. That is her goal, to get at least 62. And at least means 62 or 63 or 64, anything greater than that. All right. So how many books? Well, at least 62 books. And I'm going to go ahead and write my inequality and my solution as well. All right, we've got one more here. Connor went to the carnival with $22.50. He bought a hot dog and a drink for $3.75, and he wanted to spend the rest of his money on ride tickets, which cost $1.25 each. What is the maximum number of ride tickets that he can buy? All right, well, we know that Connor went to the carnival with $22.50, so I'm going to go ahead and put that at the very end of my problem, because that's how much money he has. He bought a hot dog and a drink for $3.75, so that's an automatic price that he's going to pay for the purchases of his items. And he wanted to spend the rest of his money with ride tickets, and each one of the rides cost $1.25. But we don't know how many rides he rode. So we're going to go ahead and represent this by saying we're going to add $1.25 times the variable x. X is going to represent our rides. Now, it does say here, what is the maximum number of rides that he can ride? Well, the maximum number is going to be that we're going to use the symbol less than or equal to, because we can't exceed the amount of money that we brought to the carnival. So no matter what the x ends up being, it has to be less than or equal to the amount of money that we brought, $22.50. So let's go ahead and solve this. I'm going to go ahead and box my variable and draw my line. I'm going to begin by subtracting $3.75 from both sides. That's going to leave me with $1.25. X is less than or equal to. Feel free to use your calculator at this time. And I'm going to finish it off by dividing both sides by $1.25 to solve for that variable. All right, that's going to leave us with x is less than or equal to 15. So to answer our question, what's the maximum number of ride tickets that he can buy? Well, he can buy 15 or less. And I'll go ahead and put ride tickets on there. All right. So in this section, we've talked about translating and applications of inequalities.